The law of conservation of mass makes us do something else with our chemical equations. It's not enough just to write what's happening. So we'll look at one of the examples I gave you before, where sodium solid reacts with chlorine gas. And when this reaction occurs, we end up with sodium chloride solid. If we look at this reaction, we have one sodium, we have two chlorines, and on the right side, the product side, we have only one sodium and only one chlorine. Well, what happened to that other chlorine atom? It can't just disappear. So we have to do something called balancing, and this is when we take the law of conservation of mass into account. So the way we balance is we're going to write a list of elements that are in our equation. So I see sodium, I see chlorine, and that's actually it. I have sodium atoms and chlorine atoms, I have sodium atoms, chlorine atoms. I'm then going to keep track of how many elements are on each side. So how many sodiums do I have on the left? Well, here's my sodium. There's no number there, so I just have one sodium. And on the right, in this compound, I also only have one sodium. For chlorine, this subscript in the reactant side tells me I have two chlorine atoms. So I have two chlorine atoms on the left, and on the right, I only have one. There's no subscript there. So I only have one. So the question is, well, how do I balance this? How do I make the number of chlorines on both sides equal? Well, the way I do that is by changing the coefficient. And the coefficient is the number that goes before my molecule or atom. So each one of these actually has a space for a coefficient. So what exactly is a coefficient? Well, a coefficient, just looking at it, is the large number written in front of an element or compound, and it is used to determine the number of molecules of that compound needed for a balanced reaction. And it's also very, very important to know that when you're balancing, you can only change coefficients and not subscripts. The reason for this is if I change a subscript, for example, if I have carbon monoxide and I change a subscript to get carbon dioxide, all of a sudden I've changed my very poisonous, deadly gas into something we breathe out. It's pretty harmless, that we deal with all the time. So by changing a subscript, we change the compound. So we can't touch subscripts. So I can't do that. So how can we change the coefficients to make this balance? Well, I need two chlorines. So the way I'm going to get two chlorines on the product side is I can put the number 2 in front. And by putting the number 2 in front of this compound, what it's really saying is I have 2 sodium chloride molecules, or formula units. So this changes the total of the number of atoms I have. Instead of having one chlorine, I now have 2. instead of having 1 sodium, I have 2 sodium chlorides. So I have 2 sodium atoms. So I've fixed my chlorine, but now I will notice that I've changed my sodium. So how can I get my sodium to balance? Well, now I have 2 on the product side. I need 2 on the reactant side. So I am going to put a 2 in front. And that means I really have 2 sodium atoms. So I have 2 sodium atoms on the left, 2 on the right. I have 2 chlorine atoms on the left. I also have 2 chlorine atoms on the right, and therefore I am done. This is a balanced equation. Let's look at a few more examples of balancing chemical equations. The first we're going to look at is sodium chloride plus fluorine gives us sodium fluoride plus chlorine. And just because we're emphasizing balancing, I'm going to leave out states for now. But we need to figure out what the coefficients are in order to balance this. So the first step is we're going to list all the elements that we see in our equation. So we have sodium, we have chlorine, and we have fluorine. Notice when I list these atoms, I ignore any of the subscripts that are with them. I just list what the atoms are. On the left side of the equation, I have 1 sodium, and on the right side, I also have 1 sodium. On the left, I have 1 chlorine, and on the right, I have 2 chlorines. On the left, I have 2 fluorines, and on the right, I have 1 fluorine. So I can pick what I have to balance. Now sodium's balanced, and that leaves me with 2 elements that are diatomic. Notice fluorine is F2, not just F. Chlorine is Cl2, so we have to go and balance those. So to balance chlorine, well, I need 2 chlorines on the left, so I'll put 2 in front here, and that changes it to 2 chlorines. And it also changes sodium. So now sodium, I have 2 of them because the coefficient tells me how many of the entire compound I have. So if I have 2 sodium chloride formula units, that means I have 2 sodiums and 2 chlorines. Now I have a choice. I can go back and balance the sodiums, or I can balance the fluorines. So let's say I want to balance fluorine. I have 2 on the left, but only 1 on the right. So I will put a 2 in front there, which will give me 2 fluorines on the product side, but it will also give me 2 sodiums. And now I can see 2, 2, and 2, and everything is balanced. So in the second example, we have sodium oxide plus iron 3 nitride yielding sodium nitride and iron 3 oxide. So the first thing we need to do is list all the atoms that we see here. So we have sodium atoms, we have oxygen atoms, we have iron atoms, and we have nitrogen atoms. On the left, we have 2 sodiums. On the right, we have 3 sodiums from the subscripts, so 2 and 3. On the left, we have 1 oxygen. On the right, we have 3 oxygens. On the left, we have 1 iron. On the right, we have 2 irons. On the left, we have 1 nitrogen. And on the right, we have 1 nitrogen. So we have to balance this. And in this case, even though oxygen and nitrogen are in there, they don't count as diatomics because we don't have them alone. They're all in compounds. That's why you don't see N2 or O2. So what should we balance first? Well, an easy one might be iron. So iron, we need a 2 on the left side because that would mean we have 2 irons. And that also changes our N to 2. Because remember, the coefficient goes with both elements here. So let's fix the nitrogen now that we just changed. So to fix that, we now need 2 of those. So when we do that, we have 2 nitrogens. But we also changed sodium. How many sodiums? Well, we have 2 Na3Ns, and if each Na3N has 3 sodiums, we have a total of 6. The faster way to do it is say, well, 2 times 3, the coefficient times the subscript, tells you how many atoms you have. So 2 times 3 tells me I have 6 sodiums now on the right. So how do I fix that? Well, on the left side, I have a subscript of 2. Well, what times 2 is 6? Well, the answer is 3. So if I have 3 in front here, 3 times 2 gives me 6 sodiums on the left. So now that's balanced. And there's a 1 next to the oxygen. So 3 times 1 would give me 3 oxygens. So sodium is balanced, oxygen is balanced, iron is balanced, and nitrogen is balanced, and now I am done. And one thing I've been doing, I haven't pointed out yet, is if I leave this blank, it is the same thing as putting a 1 there. So blank and 1 mean the same thing in chemistry. Same thing here, I could actually put a 1 there if I wanted, but I leave those things out because they are not needed. It's extra writing, but you can add them if you want. The third example we'll look at is the combustion of propane. In this example, we have carbon, hydrogen, and oxygen. We start with 3 carbons on the left, 1 on the right, 8 hydrogens on the left, 2 on the right, 2 oxygens on the left, and on the right, notice how there is oxygen in both products. So we have to make sure we take both of those into account. There's 2 oxygen in carbon dioxide. There is 1 oxygen in the water. 2 plus 1 gives us a total of 3 oxygens on the product side. What do we balance first? This is a case where we definitely leave the oxygen to last because it's diatomic. So let's start with carbon. We have 3 on the left, so we need 3 on the right. 3 times the 1 next to the carbon gives us 3. And then 3 times 2 gives us 6 oxygen total, plus 1 from the water. So now we are up to 7 on the right. Remember to take both products into account. Now let's do hydrogen. I have 8 hydrogens on the left. I have 2 here. Well, what times 2 is 8? That will be a 4. So now I know I have 8 hydrogens on the product side. And that also, though, changed the number of oxygens. I have 3 times 2, 6 oxygens from carbon dioxide. I have 4 times 1, 4 from the water, which gives me a total of 10 oxygens on the right. Now to finish, now I can use this oxygen to balance. What times 2 is 10? Well, that is 5. So now this becomes 10, and it is balanced. So to balance this reaction, it says that when 1 propane molecule reacts with 5 oxygen molecules, I get 3 carbon dioxide molecules and 4 water molecules, and mass is conserved on both sides. The last example that I'll go through with you is silver nitrate plus magnesium chloride yields silver chloride plus magnesium nitrate. So the elements we have are silver, and then notice that nitrate, NO3, appears the same on both sides. Recognize this as a polyatomic ion. So actually, I'm going to put my polyatomic ion in parentheses on this side because it's in parentheses on this side. What this allows me to do is, instead of writing N and O separately, nitrate stays as NO3 on both sides, so I will treat it as one thing, NO3. And I can do this with any polyatomic ion, if it stays the same on both sides of the equation. Then have magnesium, and I have chlorine. I have one silver, one nitrate, two nitrates, one magnesium, two chlorides, one chloride. So the first thing that's not balanced is the nitrates. Well, in order to balance that, I need two silver nitrates. So that changes this total to 2, and it also changes the total silvers to 2. Now to balance silver, I have 2 on the left, I need 2 on the right, so that changes silver. And it also changes chlorine to 2. And I'm done. So 2 silver nitrates plus 1 magnesium chloride gives me 2 silver chlorides and 1 magnesium nitrate. Keeping polyatomic ions together will save you a lot of work and make balancing much, much easier.